Up next on the virtual stage from the USA, we have MEM Computing, and representing MEM Computing is John Beane, CEO and co-founder. MEM Computing's novel MEM CPU Extreme Performance Computing SaaS delivers quantum computing performance today on any CPU or GPU. John, thank you so much for joining us here today on the virtual stage. How are you feeling ahead of your presentation?
Feel great. Thank you.
Good stuff. So same as everyone else, 3 minutes for your pitch. Massive good luck, and off you go.
Hi, I'm John Beane. I'm the CEO and co-founder of MEM Computing. We're disrupting the high-performance computing market by delivering the power of quantum computing with our non-quantum solution. Many problems, optimization problems like routing, scheduling, analytics, and AI that companies face are so large at scale that it would take years to compute an optimal solution. So companies are forced to use an approximation. This leads to cost inefficiencies that add up into the hundreds of millions of dollars annually. Now, quantum computing is working to address these problems, but quantum computing is still in its infancy, and it's at least 10 years before we'll see it at scale. And that's where MEM computing comes in. MEM computing has been live since 2019. We're solving these problems at scale in a fraction of the time that's currently required. Like quantum computing, MEM computing is a physics-based approach to computation. MEM computing is harnessing the power associated with digital circuit design in ways never before imagined. We completely reinvented standard logic gates by developing self-organizing logic gates, or SOLGs. They eliminate the bottleneck associated with current computers where the CPU and memory are separate. Instead, each SOLG is a mini processor with memory. SOLGs work together to negotiate and solve a computational problem in a single CPU cycle. Each SOLG is aware of all changes in the circuit as they occur. In physics, this is known as spatial non-locality, and it's very similar to quantum entanglement. However, we're able to do this at scale. MEM computing circuits act more like a brain than a computer. Our technology has been live since 2019. That's our virtual MEM computing machines, and it's free to evaluate. So companies are able to test their own benchmarks on their own. Our early adopters have come from the transportation logistics, oil and gas, and Department of Defense marketplaces. Our paying customers come from the United States, Japan, Poland, Spain, and Singapore. As one example of problems that we solve today, an oil and gas company came to us with a cost optimization problem associated with the delivery of crude oil from super tankers to port-based refineries. Today, they're able to solve it, provide an approximation for the solution, and it takes them 40 hours to compute that. With MEM computing, in less than 2 hours, they're able to get an optimal solution. The result is that this delivers at least $50 million cost savings on an annual basis. And this is just one of dozens of problems that this company and others like it face. We use value pricing a model, and therefore we take a percentage of the cost savings that we deliver. I'm joined in co-founding this company by the two PhD physicists, Dr. Fabio Traversa and Dr. Max DeVentre, that invented MEM computing.
Thank you very much, John. I'm afraid your 3 minutes has up on your pitch. I wanted to get you to that last page so it was on the screen. Let's go to the Q&A from the judges. Who would like to ask John the first question? I'm just going to wait until I can see your hands. Petros, off you go.
How customized does the hardware and the need to be for the specific application?
So right now, we will be developing chips and delivering our first chips in 2022. However, the technology and the circuit is so efficient that we're actually emulating the technology on CPU and GPU. We're essentially hardware agnostic.
Thank you, John. Let's go to the next question. I'm looking for the judges on the screen so I can see who's got their hand up. Jean-Francois, off you go.
How different is your technology from neuromorphic computing? It seems very similar.
So it's completely different. It's essentially a new compute architecture. You can think of it like computational memory. We've got 2 patents on the technology. and it uses physics, conventional physics, in a completely new way.
Thank you, John. Manish, Omri, off you go.
So, Joe, how much money did you raise so far, and what are your plans for next year?
So we've raised $3.25 million so far in convertible notes. We're looking to raise a $15 million Series A so that we can expand our team, and that'll help us develop the first chips.
Okay, Manish, we're probably going to have time for extra questions, so if the rest of you want to ask as well, let me know after. Manish.
Sure. You said your chip is going to come out after 2 years, but you also said that you are able to solve by a sort of a simulated environment over GPU, CPU. If it is a physical process, how are you simulating that in software or normal computing platform today?
So the technology essentially is a new digital circuit, and you're able to emulate digital circuits, which are essentially differential equations by emulating differential equations. So and it's similar to how people test out circuits before they build them. Essentially, we have our own CAD design of our circuit, and we didn't expect it to be as powerful as it is, that it's already solving problems orders of magnitude faster. The chips themselves will solve problems in real time, but we're solving intractable problems today with this with our emulation running on the cloud.
Thank you, John. Time for one final quick question, if anybody's got one that they want to put to John. Petros.
Yeah, I just want to explore that a little bit more. So, if the software solution now is up there and running and solving problems, why are you going to tapping your own chips as well?
Great question. The software will always have a market, but the advantage with the chips is we'll be able to solve real-time problems. So the first chips that we're looking at are related to computational problems associated with 5G communications, where they're going to need faster real-time solutions and also image processing. So in the software emulation isn't real-time, but again, it's orders of magnitude faster than what people are able to do today.
Thank you very much, John. We're going to wrap up this Q&A session. Thank you for bringing MEM computing to us and giving us your pitch. We're going to move on to the next startup.